The next process is an isochoric reaction. When we talked about isobaric, we used the word baric to describe barometer, pressure. Isochoric is a little bit different. I don't really know the root of choric, but it means constant volume. The object experiences a constant volume, but things may be happening. It may be increasing pressure. So if you were to think about it, here's again my cylinder filled with some sort of gas, and now it's experiencing an isochoric process, which means that there's something being done to it. It experiences a change in its energy, but that change in energy is not affecting the size of that volume. So how is that process working? Well, heat is being transferred. Something is dropping into this system, heat, or pulling heat out, keeping the object's volume constant but not keeping its pressure constant. So if you were to look at an isochoric system, thinking of that equation, that delta, because no volume is changing, then we know that an isochoric system, because no volume is changing, no work is done. I should have added that in there. Because no volume is changing, no work is done. That means that any change in internal energy of that noble gas is a direct result of heat being delivered, thermal energy being delivered. More than likely, the temperature of the object is increasing. Well, not more than likely, it is. So energy is being dumped into as a process of heat, increasing or decreasing the thermal energy in there. Now, decreasing, obviously, we're withdrawing it by exposing it to something like ice, something that's a colder temperature than it is. Or in the case of heat, you're just exposing it to some sort of heating source, leaving it out on a hot summer day, for example. So when we talk about an isochoric system, we're talking about a system that keeps a constant volume. Now, something that you probably will see on any test about thermodynamics is a pressure versus volume graph. Now, we've talked about two of the primary systems, primary processes, isobaric and isochoric. If we talk about an isobaric system, the pressure remains constant, but the volume changes. So that means that you're going to get this kind of graph. Okay? If we talk about an isochoric system, that means that the pressure changes, but the volume stays constant. So right here is the isobaric system. Here is the isochoric system. If we continue to do this and do this and this, you get a box in here, and that box is the amount of energy that's being dumped into the system. Okay, so this is actually representing the total amount of energy when you consider everything, where this box right here is the amount of energy that's being dumped into the ideal gas. Okay, so isobaric, isochoric meaning an object with a constant volume. It's not changing its volumes. So in this case, the piston expanded. Now the piston is going to stay the same, and the pressure is going to increase. And now the piston is decreasing, okay, and then the pressure drops, returning it back to its original system. So this is energy being delivered, this whole area, but this is the energy that's being transferred to the gas. Okay, so you can see there's an efficiency problem there.